Can artificial intelligence predict when the next big earthquake will strike? Right now, researchers around the world are feeding millions of data points into AI systems. Seismic readings, GPS movements, electromagnetic signals, even animal behavior. And some of these AI systems are starting to see patterns that human scientists can't. In 2023, researchers at the University of Texas trained an AI that successfully predicted 70% of earthquakes in a test area 1 week before they happened. In Japan, machine learning models are analyzing decades of seismic data to identify warning signs before major quakes. In China, AI systems monitor thousands of sensors looking for the telltale signals that an earthquake is coming. So, here's the question. Can AI predict when the big one will hit? And if it can, why aren't we using it already? The answer is more complicated than you might think. Let me show you what AI can actually do right now, and what it means for you. For decades, scientists have said the same thing. Earthquakes cannot be predicted. Not tomorrow, not next week, not next year. The best we can do is prepare. But what if that's changing? Imagine if we could predict earthquakes the way we predict typhoons. If Vival CS could announce a magnitude 7.2 earthquake will strike Metro Manila at 3:47 p.m. next Tuesday. The lives that could be saved, the damage that could be prevented, the disaster that could be prepared for. But unlike typhoons, which we can track forming over the ocean and predict their path days in advance, earthquakes happen deep underground, hidden from view. And the physics of how earthquakes work makes prediction extraordinarily difficult. To understand why AI might help, we first need to understand why earthquake prediction is so hard. Earthquakes are caused by stress building up along fault lines, two tectonic plates grinding against each other. The rocks catch, pressure builds. Eventually, the stress becomes too great, and the rocks suddenly slip. That sudden slip releases all the stored energy at once. That's an earthquake. The problem is that this process is chaotic. Small changes in conditions can lead to massive differences in outcomes. Think about stacking books on a table. You keep adding books, one at a time. You know eventually the stack will fall. But can you predict exactly when? Which book will be the one that causes the collapse? Will it fall forward or backward? You can't. There are too many variables. A tiny vibration, a microscopic shift, air currents. Any of these could be the trigger. Fault lines are the same, but infinitely more complex. Scientists can tell you that stress is building. They can estimate that a major earthquake is likely within the next 100 years. But they can't tell you if it will happen tomorrow or in 50 years. This is why Vivolcas and seismologists around the world have consistently said earthquakes cannot be predicted with any useful precision. But what if the patterns exist and humans just can't see them? What if there are precursor signals, tiny changes in seismic activity, ground movements, electromagnetic fields that occur before earthquakes, but they're too subtle or too complex for humans to recognize? This is where AI comes in. Modern artificial intelligence, particularly deep learning and neural networks, excels at finding patterns in massive data sets that humans can't see. AI can analyze millions of data points simultaneously. It can detect correlations between hundreds of variables. It can learn from every earthquake that's ever been recorded. And unlike humans, AI doesn't get tired, doesn't have biases, and can process information 24/7 in real time. So researchers are asking, can we train AI to spot the warning signs of an earthquake before it happens? Let me tell you about some of the most promising research happening right now. In 2023, researchers at the University of Texas at Austin trained a deep learning AI system on seismic data from a network of sensors in Texas. The AI analyzed patterns in low-level seismic activity, the constant background rumbling that happens along fault lines. After training on 7 months of data, the AI was tested on a 5-month period. The result? The AI successfully predicted 70% of earthquakes 1 week before they happened. Even more impressive, it had very few false alarms. When the AI said an earthquake was coming, it was usually right. Now, there's a catch. These were small earthquakes in a well-monitored area, not magnitude 7.0 disasters. But still, this was a breakthrough. At Los Alamos National Laboratory, researchers trained an AI on laboratory earthquake simulations, literally creating mini earthquakes in the lab with specialized equipment. The AI learned to recognize acoustic signals that preceded the earthquakes, subtle sounds and vibrations that occurred in the seconds before the rocks slipped. When tested, the AI could predict when the lab earthquake would happen with surprising accuracy. The question now, does this work in the real world, with real faults at real scale? Japan, which experiences thousands of earthquakes per year, has been at the forefront of AI earthquake research. The Japan Meteorological Agency has been developing machine learning systems that analyze seismic wave patterns, GPS ground deformation data, ocean floor pressure sensors, and historical earthquake sequences. These systems look for patterns in foreshocks, the smaller earthquakes that sometimes precede major ones. While the system can't predict specific earthquakes, it has improved early warning times, the seconds or minutes between when an earthquake starts and when the shaking reaches populated areas. China has deployed thousands of sensors across earthquake-prone regions and is using AI to analyze the data in real time. Their systems monitor seismic activity, ground deformation, groundwater levels, electromagnetic signals, and even unusual animal behavior. Chinese researchers claim some success in medium-term forecasting, identifying elevated risk periods of weeks or months. But they haven't achieved the Holy Grail, specific prediction of when and where an earthquake will strike. So how does this actually work? What is the AI looking at? AI needs massive amounts of data. Seismologists feed the system decades of seismic readings from thousands of sensors, GPS data showing ground movement, strain data from instruments that measure stress in rocks, electromagnetic readings, and historical earthquake catalogs. The more data, the better the AI can learn. The AI uses neural networks, computer systems modeled loosely on how the human brain works, to analyze all this data simultaneously. It's looking for patterns, correlations, sequences of events that precede earthquakes. Maybe before a major earthquake, there's a specific pattern of small tremors, or a characteristic change in GPS measurements, or a combination of multiple subtle signals that, together, indicate an earthquake is coming. The AI learns by trial and error. It makes predictions, sees if they're correct, and adjusts its internal models. Once trained, the AI monitors real-time data streams from seismic networks. When it detects patterns similar to those it learned during training, it issues an alert, elevated earthquake risk detected. This is the hard part. Does the earthquake actually happen? If yes, the prediction was successful. If no, it was a false alarm. And this is where earthquake prediction AI still struggles. Despite the promising research, AI earthquake prediction faces massive challenges. Imagine FIVO-LCS issued an AI-based warning. High probability of magnitude 7.0 earthquake in Metro Manila within the next week. The city evacuates, businesses shut down, schools close, billions in economic losses, and then nothing happens. How many false alarms would people tolerate before they stopped listening? The 2009 L'Aquila earthquake in Italy illustrates this problem. Scientists failed to predict the earthquake, and 6 were later convicted of manslaughter for providing false reassurance. The convictions were later overturned, but the case shows the no-win situation scientists face. If AI prediction systems have a high false alarm rate, they become useless, or worse, dangerous, because people stop believing them. AI learns from examples. The more examples, the better it learns. But large destructive earthquakes are rare. A magnitude 7.0 plus earthquake in any given region might happen once every century or longer. There simply aren't enough examples for AI to learn from. The University of Texas study worked because they were predicting small, frequent earthquakes. When it comes to rare, catastrophic events, we don't have the data AI needs. Some scientists argue that earthquake prediction might be fundamentally impossible, even with AI. Earthquakes are chaotic systems. They're inherently unpredictable in the same way that we can't predict exactly when a stacked pile of sand will collapse, even if we know it eventually will. No amount of data or computing power can overcome fundamental physical limits. Even when AI successfully predicts an earthquake, the time window is often too broad to be useful. Saying, "There's a 70% chance of an earthquake in the next week," is very different from saying, "An earthquake will happen at 3:47 p.m. tomorrow." The first might be scientifically achievable. The second probably isn't. And without precise timing, how do you prepare? Evacuate a city for a week? So back to the question. Can AI predict when the big one will hit? The honest answer, not yet. Maybe never. But AI isn't useless for earthquake preparedness. Here's what it can do right now. AI can improve earthquake early warning. The seconds or minutes of warning after an earthquake starts, but before the shaking reaches you. When an earthquake begins, the first seismic waves, P waves, travel faster than the destructive waves, S waves. Sensors detect the P waves, and AI can instantly calculate earthquake magnitude, location, expected shaking intensity in different areas, and time until shaking arrives. This gives people seconds to take cover, trains to automatically stop, gas lines to shut off, operating rooms to pause surgeries. Japan and California already use these systems. FIVOLCS is working on implementing similar technology. Seconds of warning can save lives. AI can analyze geological data, building structures, population density, and historical patterns to create detailed risk maps. This helps city planners identify which buildings need retrofitting, which areas need evacuation routes, and where to position emergency resources. After a major earthquake, aftershocks continue for days, weeks, or months. AI is getting better at predicting where and when aftershocks will occur. This helps emergency responders know when it's safe to enter damaged buildings. While AI can't predict the big one, it can monitor fault lines 24/7 and alert scientists to unusual patterns that warrant further investigation. Maybe the AI detects a change in seismic activity or ground deformation that's different from the norm. That doesn't mean an earthquake is coming, but it means scientists should pay closer attention. So what's the future of AI earthquake prediction? In the next 5 to 10 years, we'll likely see better early warning systems that give us more seconds of warning and more accurate predictions of shaking intensity. We'll see improved risk assessment that helps cities prepare and strengthen infrastructure. We might see possible medium-term forecasting, identifying periods of elevated risk over weeks or months, though still not precise prediction. But the Holy Grail, predicting specific earthquakes days or weeks in advance with precision, remains elusive. Some scientists believe we'll eventually get there as AI improves and we gather more data. Others believe it's fundamentally impossible, that earthquakes are too chaotic to ever predict precisely. So what should people do with this information? Don't wait for AI to predict the big one. FIVOLCS has been clear. They cannot predict when a major earthquake will strike. And AI isn't going to change that in the near future. Maybe in 20 years, maybe in 50 years, maybe never. What you can do right now, prepare as if it could happen tomorrow, because it could. Build or retrofit homes to earthquake-resistant standards. Maintain emergency kits. Practice earthquake drills with your family. Know your evacuation routes. Better data helps both human scientists and AI systems. Support FIVOLCS and their monitoring networks. When AI earthquake prediction technology does improve, FIVOLCS will implement it. Follow official sources for updates. If someone claims they can predict earthquakes with AI, be very skeptical. No commercial AI system can do this reliably yet. Can AI predict the next big earthquake? The short answer, not yet. The longer answer, AI is showing promise in improving early warning systems, identifying risk patterns, and maybe eventually providing some degree of forecasting. But precise prediction of specific earthquakes, days or weeks in advance, remains beyond our reach. What AI can do is help us prepare better, respond faster, understand the risks more clearly. And that might be the more important question anyway. Because even if we could predict earthquakes perfectly, if we're not prepared, people will still die. So while scientists and engineers continue pushing the boundaries of what AI can do, the rest of us need to focus on what we can control: preparation. The big one is coming. It might be tomorrow. It might be in 50 years. But whenever it comes, the question isn't whether AI predicted it. The question is, were you ready?